Hi, and welcome to this video about how to control a simple cube in SolidWorks with some code in Visual Studio. So the first thing that we're going to do is to create the cube shape. So let's start a new part in SolidWorks. Let's create a sketch on the top plane. Let's go with a center rectangle. Like that. Let's put out some dimensions so that we have something to control. 100. We can name this dimension. Name it width. Oh, sorry. Width. Like that. And let's call this one perhaps depth. Then we can extrude this. So let's do an extrusion. Do that 200. Sure. And that if we double click mass extrude, we will get our 200 dimension. And let's call that our height. So now we have a sort of cube. We have 3 dimensions. We've named them so that we can reference them easily. So let's start creating our app, our program that is going to control this. So the type of app that we will use today is a Windows Forms app with the .NET framework and C# as the programming language. So I've recently used one of these, otherwise you can search for this template, but I will choose it here and create next. I will name this cube video. I'll save it in the default location. So let's create this project. Once inside, we will start by adding references to SolidWorks, because we want to use SolidWorks commands inside of our program. So we have to add them as references. So right-click on the references out to the right and do add references. I've added some before, but let's do it the long way. So we have to browse for 2 files from the SolidWorks. These are located down in the SolidWorks installation folder, so program files, SolidWorks Corp, SolidWorks API, and redistributables. So we have 2 files here. It's the solidworks.interop.sldworks.dll and solidworks.interop.swconst.dll. I will select both of them and add both, and then click OK. So now these are added to our list, to our references list here. Should be here, SolidWorks references. Good. So now we can reference SolidWorks commands in our code. So to control and be able to get a connection to SolidWorks, we will create a new class that we are going to call SolidWorks Singleton. This is a method or a way of doing it that I have gotten from another video. I will link that in the video description so you can have a closer look and get a deeper explanation about how that works. But I won't go through that. I will just copy code that I've pre-made. So we will just get that, and then we will get to connect to SolidWorks. So let's right click on the project name up here and do add class. As I said, I will name this class SolidWorks Singleton.cs for C#. Click add, and here we get a new class file. So I prepared this code, so I have it here. Let's copy and paste that code, and we will have it inside of here. So I will remove the existing class code and replace it with my own. So we get a couple of errors here. It's because we haven't, the references that we added, we need to tell the program that we are actually going to use these as well. So let's add a few lines up here. We need to be using solidworks.interop.sldworks. And we also need to use, because we get an error on the Marshall command, so using system dot runtime dot interop services to be able to use the Marshall get active object so that we can get a connection to SolidWorks application here. Okay, so let's save this and then get to work. So let's head over to our forms design. In here we will add a couple of a button and a couple of text boxes. So let's see, let's add a button first. So we will drag and drop from our toolbox a button. Let's make this a bit bigger. So this is going to be our update button that we click to update the SolidWorks model. So the text on the button will say update. So we have all the properties out here. So the text for this button is now update. And then I will also change the name, perhaps the size, the name for this button, so that I will be able to identify it in code, because right now the name is button 1, it doesn't say that much. So I will use naming convention that the buttons. I will start the naming with btn for button, and then the name that is more connected to what it does. So I will call this btn update. All right, then we will add a couple of text boxes, one for each dimension that we want to control. So text boxes, text box, yes. So we won't focus on making the design of the form particularly pretty or well built. We'll just add the bare essentials and then see how we control the cube. So I will copy and paste 2 more text boxes, and then we can stack them up like this. Then we can name them appropriately. So the first text box, let's call that width. I will start text boxes with the prefix txt so that I know if it's a text box. And then we'll start with width. So txt width. Then I will also add a label out here so that we know which one is which. So I will add a label there perhaps, and the text of that label. We'll scroll down to text, and that label will say width. So now we know. Then the next text box, we'll name that depth, I think was the next. Txt depth. Yeah, copy and paste the label like that, and change that label text to depth, right? And then we have the height. So I will select that text box, change the name, txt height, and add a label there, copy and paste, and then, yeah, and just change the text of that to height. Right, so this is basically going to be our complete user interface. So not that exciting, but it will do the job. So now let's add some code to this. So basically most of our code is going to be in this program will be within the event of us clicking the update button. We won't structure our code in a more sophisticated way. We will just add the code, all the logic into the click event of the button. So let's double click the update button here. Then Visual Studio creates, first of all, we get to see the code for the form class, form1 class, and it creates a new function for us that is the event of us clicking the button, and then within the brackets our code. We can add our code, what should happen when we click the button. So first, in this forms class up here, we will add a couple of rows. I will add objects or variables for the SolidWorks app object. As a SolidWorks application, I will add an object for the current document, so a SolidWorks model, so that we can control our cube. So up here, let's add 2 rows. We will, first of all, I will add some comments. You add comments in C# by doing double slashes. So we will get SolidWorks. We will do that, or not get SolidWorks, but we will create the objects, the variables. So it is going to be all right, forgot. We need to add the same using. We can't reference SolidWorks commands if we don't add these rows. Using solidworks.interrupt.sldworks and end with a semicolon. So the object type for our variable is SLDWorks, that is the program. I will call this variable SWApp. so that we have a placeholder for that. And then for the document, the SolidWorks file that we have opened, our cube in this case, this is a model doc. We have two variants. The newer one is model doc 2. So it's a type model doc 2, and I will call that SW model. So we will have this, our form will get to have these properties or these objects. So after we initialize the user interface, so that we get to view our user interface, our form, we can add the code for actually populating these two variables. So let's add code inside the initialization process, or under the initialize component. So we get the SolidWorks. Then we set SW app, that is of type SLDWorks. It should be. So now we get to use our SolidWorks Singleton class. So now we do SolidWorks Singleton dot get application. So function, so we need to add parentheses, and then so this get application, it will get, if we have a SolidWorks instance running or the program open, it will connect to that. Otherwise, it will start a new SolidWorks session for us, basically. After we have that, we can get the open SolidWorks document. So we tell it to set SW model to, and now we can use SolidWorks API calls. So now we can tell SolidWorks app, SW app, to set SolidWorks model as active doc. So now when we start our program will connect to SolidWorks, and it will populate this variable with the active document in SolidWorks. So we need to make sure that we have our cube open when we run the program. Otherwise, we'll probably run into some trouble. All right, then we can add code into our button when we click the update button. So we can start with having SolidWorks just rebuilding the model. So we will start with that. So we will tell SolidWorks that the model dot force rebuild. Force rebuild is a function. It takes a Boolean input that is described as top only. If we don't know what that is, this is documented in the SolidWorks API help. So in this case, I have this open here, so you can just Google for SolidWorks API help. Once you get here, you can search. So in this case, I know there's a function called force rebuild. So let's search for force rebuild. Looks like I've done that before. So force rebuild method for model, force rebuild 3. That is the one that we use for model doc. So let's see, what does that do? Well, it's overwritten, so it's superseded with a new one. So let's check that. Okay, seems to be the latest one. Okay, so it takes a parameter top only, so it's a Boolean, true or false. So true rebuilds the top level assembly only, false rebuilds the top level assembly and all sub-assemblies. So it really only makes sense in when we deal with assemblies, so probably doesn't make any difference for parts, but the most complete rebuild rebuilds the most of our documents if we set it to false. So in this case, I will set this to false. And then, of course, the semicolon. So now we can try and test our program to see if it works, if we manage to rebuild our model. So let's head back into SolidWorks. I will change the extrusion value from 200 to 400, but I will not rebuild it. I changed the variable, and now we can see if our program is able to rebuild the document. So let's head in. Let's try and build and start our application. And let's see, let's put SolidWorks in the background. So here, so let's just click update and see what happens. Yeah, seemed to work. It became taller, so the code seemed to do its job. So let us close our program. I will change this back to 200. So the next step is just to make us able to input values in our text boxes and put that information into SolidWorks as well. But first we will make our application a bit more user-friendly. So we will actually, when we start our program, it will read the values from these 3 dimensions and populate that into our text boxes so that it looks nice. So we get the current values first, and then we can choose which one to change. So let's see. So we will do that under the initialization. So under here, we will do that. So I will add some code. I will populate text boxes. Like that. And then add some code. So in this case, we will use from the SolidWorks model. There we have some parameter, and those are we just have to input the names of our parameters. So let's see. Let's copy a name of one of our parameters from SolidWorks so that we don't spell it wrong. So let's start with the 100, that's the width. So I will select that and then copy the complete name. So copy that into here. Since it's a string, I need to add quotation and then paste it. So the parameter, it has a dot value from SolidWorks. So what that does, there are actually two different variants here. You can do dot system, then you will get the value of the parameter in meters in the well, system units, that is meters for SolidWorks. If you do dot value, as I've done here, you will get it in the current units settings for the part, in my case millimeters. So in this case I will get the value in millimeters. However, it's a dynamic, so the type of object, so I know from experience that we will get a double from this, but Visual Studio doesn't know that, and we need to convert this into a string. So perhaps there are better ways of doing this, but I will do it in this way. So I will first create a new variable called my value. And then I will set my value equals to this value that we get from SolidWorks. After that, we can do the conversion because now we have it as a double. So now we can put it into the text box, into the corresponding text box. So since we deal with the width here, we can do txt width dot text. So setting the text of that text box should be equal to, and now we can do my value dot toString. So we convert the decimal number that we get to a string. And we don't need to add any inputs there or arguments. So now we will have that populated. So let's do in a similar way for the other two. So I will copy these 2 lines of code and paste them 2 more times. Like that. Then first we will change. So we'll grab the next dimension name. It's depth at sketch 1. So I will go back and paste that here. Like that. So it says depth, and then it should be txt depth, so that text box. And then for the last dimension, it's this 200, it's the height at boss extrude 1. So copy that. No. Like that, paste, and txt height. Like that. So let's try it out. Let's see if our text boxes get populated. So let's start the application, see what happens. Yeah, nice. It works. So yeah, good. So now we only need to send these values back to SolidWorks when we update, and then we are done with our application. So let's close it. And then we have to add the code to the update button where we set these. It will be almost the same code as here, but in reverse, so that we will set these values instead of the text boxes. So let's do that down here in the click event function. So I will copy. So I will do it in the same order. So I will copy that parameter .value, copy, and paste it here. And say that this value should be equal to. And now we need to deal with the conversion again, because the text in our text boxes are strings, and we need to input doubles here. So let's do convert. So there's some functionality here which can convert different data types to other. So we do convert dot to string. Oh, sorry. Convert to double, obviously. To double. Convert to double. What do we want to convert? Well, we want to convert txt width dot text, because that is a string and we want to convert that to a double. Yes. And then we do the same for the others. So I will copy that line 2 times. There. And copy these values. So the name. that, and then the correct text boxes. So txt depth and txt height, like that. And let me add a comment. So update the dimensions in SolidWorks and converting the numbers in the text boxes to doubles. Yeah. Let's try it out. So let's start. And I will put SolidWorks in the background like that. Perhaps we can do like so. So width, let's bring that up to 300 perhaps. Depth to 100 and the height to 400. And update. Wow, yeah, went a bit too far, too big. Yeah, seems to work. Nice, since it got, when we do it too big, so let's do this 1000, then it goes outside of our view. So what we can do is to, if we close this, go back, so what we can do is to make it zoom to fit afterwards. So after we rebuild it, we can zoom to fit. So let's see, there's some code we can do at the model, SW model dot, we can do view zoom to fit. View zoom to fit 2 seems to work. Yep. Don't need any inputs or arguments. So now we will tell SolidWorks to do that. So let's try that as well. Start the application. It's SolidWorks in the background. And yeah, we can just run that and see if it zooms to fit. Yep, seems to work. Nice. So we have done a very simple application in Visual Studio with C# that updates our very simple SolidWorks model, but with the principle that you can use the names of different dimensions and parameters in SolidWorks and set and get values from them, and then update your model, can become pretty powerful. But in this tutorial, we did it very simple. So you could imagine what happens when we input a width that is not a number, for example. Then we will get errors. So we might have to add some stuff to our code to handle some bad user inputs and stuff like that. But we will check that out in later tutorials. So that's it for this time. Thank you for joining.